Well, good morning. And I'll follow the panel that was just here with what they were saying to our host. This has been an amazing visit. Thank you so much for your hospitality, and we certainly do appreciate it. Well, what I wanted to talk about, which again most of the panelists have alluded to this morning, is the manned part of unmanned systems. And it goes all the way back to what Frank mentioned in his first presentation this morning, when he said that in the future, we're going to have to be able to just go out and file a flight plan and fly these vehicles. So the challenge is, how do we get to there from here? And we've talked a lot about the technology today that will allow us to do that, but there's one more piece of that puzzle that will allow us to be successful, and that's the people piece. And again, if you think unmanned systems don't have a human component, I would argue that that's probably not true. It's a very critical component, and the people that we select to operate these systems, and then how we train these people to be effective utilizers of these systems becomes very critical. So I want to talk about training standards, certifications, and other human factors, but the reality is that in many of these cases, in particular in the civil world, these training standards do not exist. As mentioned before, most of the regulators out there have not identified what the certification standards are. In the United States, of course, where I'm from, we're teaching folks to do flight every day. Hundreds of pilots a year we're training. But we have clearly identified, the regulatory environment and the industry has clearly identified what those criteria are to become a certified pilot for a manned platform, of course. In the unmanned system, that criteria has not been identified. So from a training perspective, what are we doing? We can offer best practices. We can look at our industry leaders who have established training protocols for operating their vehicles in certain mission criteria, but that does not result in a certificate of operation into a civil market. So the training standards and the certifications, I'm going to tell you, there's no clean answers here, and I don't have any direct answers to tell you exactly how it should be, but I will tell you that the industry and large research institutions around the globe are working on some very key components that are related to the human factors of how these training standards will be established and what certification will be that will allow us to successfully integrate unmanned systems into airspaces around the globe. So what are those key areas that pretty much everybody's focusing on, from industry, from educators, from researchers, but also from the regulatory environments? And if I narrow those down to about 7 different components from a human factors perspective, you're going to see them here on the screen in front of you. That human automation interaction. We've talked a lot about automation this morning, and automation is critical to the unmanned systems, but there's also a risk with automation, and I think we're all familiar with that. Let's look at that just real quick. Sorry. We're going to look at the ground control stations and the design of those systems. I think that was mentioned a little bit earlier this morning as well, the standardization challenges you have there. The display of traffic and aircraft and airspace information. How do we take an operator of unmanned systems and give them the information they need related to operating in a commercial systems with both cooperating and uncooperative aircraft, how to safely operate in that system? And if you think about it, an MQ-1, a Predator, can operate up to, the XP you saw this morning can operate up to 25,000 feet. At 25,000 feet at 120 knots, do you simply need to look ahead of you for traffic? I don't think so. Just about everybody else in that airspace with you is going to be going significantly over 120 knots. So there's a context with unmanned that's a little different that we need to consider. And then the contingency management information. What do we do when risk is realized, when we've lost link? How do we interact with that, and how do we do it safely? If safety and trust is the key to operating in the airspace system, then how do we do that from a contingency perspective? We have to define the roles and responsibilities of the operators. Now, that's pretty straightforward in a manned aircraft. You have crew resource management, CRM, that we refer to. We've got very good at that. It's had tremendous benefits. That's basically how the crew on board the aircraft interact with each other. In the unmanned system, that becomes completely more complicated. Not only do you have the operators, but in many cases you have a mission controller. you have ATC, but you can also have your maintenance folks that are involved in identifying and finding a solution to certain emergency situations that have to be brought into this concept of who does what and when. Human performance requirements, what are the skill set that we're looking for? And then this all comes together to say, what does the qualification and the training need to be? Other areas in the unmanned systems that a lot of us are involved in research or to solve these questions that you see before you, they've been mentioned this morning, not going to spend much time there. Inability to avoid collision, the sense and avoid concept, the ability to maintain positive control, what happens with lost link, inability to meet the operational expectations of the environment you're operating in, which is this ability to, can you separate from other operators? And then the ability to safeguard the public, which is obviously critical. If you went to the FAA or a lot of the regulatory agencies around the world and you said, what are the key challenges that you would see, they usually break them down in what you see there before you on the screen. And that's broken down by the operator, by the vehicle itself, by the command and control. And you can see those areas, those aspects under that to make it a little bit different, where we have to give it a little more attention, a little more research to find the right solutions to do this safely as we're establishing training standards and qualification criteria. And you'll see a lot of those have a human factors connection. So let's start with the automation piece of this. Automation is important in aviation. It saves money. It creates safety. We would all say that that's without a doubt. If you think about autopilot and auto throttles, just that simple level of automation, the ability to precisely control the aircraft and efficiently control the aircraft are vastly improved through automation. So that's true. Human-in-the-loop type automation, we've seen the value of that. But automation has not been a cure-all. As good as we're getting with it, it hasn't been a cure-all. There's our risk. There are challenges that have been established by the use of automation. And some of these, now this is just generic in nature, but there are a risk that we would have a reduction in operation system awareness. You better monitor more than an operator. That allows you to kind of lose your SA and what's going on around you and exactly where you are in the environment. There's a risk of increased training requirements. We've seen that many times before, where you introduce a new component to the aircraft and the training that goes with that becomes sometimes very burdensome when combined with all the systems on board. There's a risk of increase in a mental workload. As with automation and technology becomes capability, and with capability usually becomes a workload. There's more things you can do, there's more things you need to be doing, so it moves a lot away from just operating the vehicle into managing the vehicle and managing the systems on board, and that can have a mental workload. And then there's a degradation or an argument or a risk that there could be a degradation in flying skills. When we look at these accidents that have occurred out there that have a direct relationship to automation and how the human and automation interacted that resulted in an accident, there's some common threads. Now, most of these common threads are established out of data from manned aircraft accidents, of course, because it's not necessarily being recorded in unmanned areas now. But these common threads, I think, would apply as we're considering training standards and certifications moving forward. They'd apply to unmanned aircraft as well. And that, as I mentioned before, reduction of situational awareness, a lack of awareness of control settings, the lack of mode awareness, which has been evident in some unmanned accidents that have been studied out there, where the pilot moved to a sensor operator station and was unaware of the configuration of that station and lost control of the vehicle. Not by any failure on the vehicle, but just a lack of the operator to be able to move into an environment that was configured a little different and overcome that, recognize that and overcome it quickly. Inability of automators, designers to recognize every contingency out there. And this one is, I think we've all probably remember the Air France accident that came out of Brazil. I believe it was in 2009, but don't quote me on that, where they were at high altitude and they entered clear ice at high altitude, icing situation that froze up the PDOT. So the autopilot system on board the aircraft experienced a situation where it was not getting the information it needed at high altitude. Nobody had expected that you would enter a situation like that and the automation system would respond the way it did. By the time the pilots recognized what was going on, they could not recover it. They got the vehicle into a deep stall and of course lost it. There's other examples where automation was a challenge here, where there was things that happened that the designers of the automation did not realize, and the human had to overcome those. The Singapore Airlines, the Qantas Airlines, I believe it was, no, it might have been Singapore, the A380 that was flying out of Singapore is Qantas, that had the engine, the turbine that separated and penetrated the fuselage, caused significant damage, and damaged some systems on board the aircraft that created a situation where the pilots could not transfer fuel due to automation saying that, no, this is not how we handle this situation. So there's things out there that designers of automation cannot predict. And that can be a challenge, that can be a risk. And in those situations, we have to have the human in the system to be able to overcome that. And as we develop training standards and certifications for the unmanned systems to safely operate them, to develop this trust that they've been talking about this morning, we've got to have that as a consideration as we build these standards. Let's look at GCS designs real fast. And if you have not had a chance yet to go out to the tent here, where Frank was mentioning this morning, their Block 50 ground control station that General Atomics has built is amazing. Go take a look at it. It's significantly different than the traditional MQ-1, MQ-9 ground control station that you see out there today. It's amazing, and they're taking giant leaps forward. But there's challenges in the unmanned world with ground control stations. And a lot of those challenges are because there's no standardization between the systems. And if we look here, you can see this, you recognize this probably as a manned aircraft. This particular one is a 787. Let's see if I can make the laser pointer work there. And I can't. But you can tell where the rudder pedals are at. You would recognize that as a pilot. You can see the yoke. You can see the throttles. You see what's going on there. Now, if we move from this aircraft to an Airbus A380, it looks a little different, no doubt about it. But you can still clearly see where the control stick is at. You can see where the rudders are at. You recognize the throttles. It's a common environment. Now, there are accidents and there are risks involved in moving pilots between one aircraft to another aircraft systems, even into newer versions of similar aircraft when you get into emergency situations where the pilot has to respond almost by habit. There are challenges there. And you can tell that between these two aircraft there would be challenges. But basically, if I put the cockpit of maybe something like a Cessna 172 or an early training aircraft, you would still recognize the components. It would look familiar to you even on something as modern as a 787 cockpit. But when we move forward into the unmanned systems, things don't just change, they change significantly. Some of the ground control stations that you can see. Now you see that in lower left there, you can see that's an MQ-1 operating system, but some of them are simple as laptop control systems. And then we can not only change the types of ground control stations, we can change where the ground control stations are located. And when you move them into a mobile environment, it changes the environment that you're operating in. There's a human component to that we must be aware of when we establish training standards and criteria. And then we move to different size unmanned vehicles. And if you notice the gentleman flying the aircraft in the lower left screen, he's using basically a smart device with some type of hood so he can see it in an outside environment. The operational environment that this gentleman is involved in is significantly different than the gentleman in the lower left there. So how do you establish standards and criteria that would allow you to safely operate these vehicles when there's that much difference in control systems? We certainly can do that, but it's things that we have to be aware of as we establish these training standards. It's not as simple as it might first appear. Significant difference in how the standardization of the ground control station is something we must consider. Let's look at the display of traffic and airspace information. This is an unknown. What's the best way to do this? And we have things that we're studying for the next generation of air traffic control systems, next gen, called ADS-B. And this allows even an aircraft that might not have the TCAS type of collision avoidance systems that most large commercial aircraft would have, to have the situational awareness that those larger aircraft would have to avoid traffic. We'll obviously have to have some component of that or some some capabilities similar to ADS-B on board an unmanned aircraft system too. But how does that display to the pilot? And is the way we display it today in manned aircraft the most effective and productive way to display that to an unmanned aircraft system operator? We need to explore these things. We need to figure these out. And as I mentioned in the opening marks, at 25,000 feet at 100 knots, you need to look over your shoulder, not only out in front of you, to make sure that you're deconflicting with other aircraft. The see and avoid and the sense and avoid question is probably one of the more technical problems that's being solved now. We heard this morning from Frank how General Atomics is solving that by having a radar system looking forward out to 10 miles. And the pilot can manually deconflict. And then at a certain point, technology and automation takes over and would automatically allow the aircraft to deconflict. These are wonderful technologies. That's a large platform he's operating with, as the gentleman spoke this morning from Textron. Not everybody has that kind of capability on board their systems. So how do we find other ways to be able to meet these same critical criteria of sense and avoid? And if most of you that are familiar with manned operations, the bottom line is if you're in control, even in controlled airspace, the ultimate responsibility relies on the pilot to see other traffic and avoid it. Now, a lot of technology comes into place to make that happen, but how do you do that with an unmanned system if you're operating from 130-degree view, a field of view? There's a challenge there. Technology is going to help us with that, but we've got to consider those things when you're talking about how the human is integrated into this, and particularly in how you're going to train, what kind of skill sets you're going to look for, and what the certification criteria will be. Contingency management. Most of our aircraft today, unmanned systems today, follow a very simple procedures. If you have a lost link or if something goes wrong with the aircraft that would take it into a safe operating environment. But you've got to realize the defense departments, the military components are what's driving most of this today for good reasons. That's where most of this operations is occurring. But they're operating in areas that are usually unpopulated and where these type of contingency efforts make sense and they're the most effective. Climb to a predetermined altitude and wait. See if you can establish control again, establish the link again. That's a very common one. Circle with the predetermined waypoints. Go out and fly a racetrack and see if they can grab you or return to base. In many cases, it's just divert to an unpopulated predetermined area and stay there until you're out of gas. But those type of safety protocols become a challenge when you start talking about wanting to integrate into the commercial national airspace system with other aircraft over populated areas. I can tell you that I flew into town on, sorry, it's all going to get it now. Oh, late Friday night, early Saturday morning, I flew into town and flew into Dubai, and there was the dust storm that I think most of you are aware of. So we held in UAE airspace just east, I guess a little bit northeast of here. And there were a lot of big airplanes and a little bit of airspace. And at that point, I was very thankful that we did not have UAS in the area, hopefully not in a contingency environment where they were directed to that airspace along with us just to hang out, because it was pretty crowded out there. So when we talk about that kind of crowded airspace and over civil market, over large cities, urban populations in some cases, those contingency plans that we have in place today might not be the most effective. So we got to consider that going through our training procedures as well and criteria. Let's look at some of these. We mentioned these a little bit earlier, but again, in traditional crew resource management, or CRM, we're going to talk a lot about how pilots work together to solve problems on board the aircraft. That's going to still be true, except for on board the aircraft and unmanned systems. But there are a lot more people involved in that, a lot more stakeholders, I guess is the way to say that, involved in the operations of unmanned systems. If you talk to most UAS or Predator or MQ-9 Reaper type operators, they tell you basically everybody in the Air Force is in the back of the airplane with them, because it's how it feels sometimes, because there are a lot of stakeholders that's right involved looking over your shoulder as you're dealing with sometimes emergency procedures. So how do you set up the training environment to be able to compensate for that? It's beyond the current manned CRM we have today. We have to contend with the avionics technicians that might be doing maintenance on the ground control station, or fixing components on the ground control station that's causing the emergency. There might be maintenance personnel that's out there with the aircraft. You have mission commanders in many cases. Other times you have intel people that have a stake in what's going on in the successful resolution of the problem you're experiencing. Once we move into controlled airspace, commercial airspace, we'll have the ATC component, the air traffic controllers, that we all have to figure out how to work together. So CRM in the future will certainly look different than it does today for manned aircraft. So how is it going to look different? How do we take Crew Resource Management and turn it into focusing on the human-computer interface? The Block 50 GCS is a classic example of that, where they've changed the field of view from what you would have with your camera looking forward using synthetic aperture radar and taking that out to 130 degrees. That's a great example of how we can help the human in this loop. We got to mitigate mission fatigue and complacency. We know the I think it's the 3Ds, the dull, dangerous, and dirty, right? And a big piece of that is the dull missions that UAS are really effective in, but there's a complacency component to that, especially if you become a monitor of a system a system that's heavily automated. So we have to consider that in our training standards and in our certification levels. Safely compensating for not only temporal lag, but system lag. Frank gave a great demonstration this morning, an explanation in slides that showed how we went to a satellite control system now, but with that satellite control system, even with the modern technology we have today, there is a lag in performance, where the pilot introduces an input and the aircraft responds at a certain period after that. Now that's been reduced significantly through technology, but the lag is still there. There's also this deprivation of senses that you'd have because you're not on board the aircraft. All of you that fly manned aircraft, if you take off and you get in wake turbulence, you know it immediately. You know it before your gauges indicate, or your instrumentation indicates that you're in wake turbulence. You feel it. But on this aircraft, on unmanned systems, we have to rely on our systems, on our instrumentation to give us that type of feedback. There's a lag there. We've got to compensate for that in our training, in our development, and our certification procedures. And then the basic CRM issues become critical in this area as well. Human performance requirements. Who do we recruit to operate unmanned systems? And are they the same type of candidates that we recruit today for manned aircraft? We had a panel on Saturday where we sat and talked with leaders of flag officers from several different military organizations, where they were talking about recruiting members into the technology-enhanced Department of Defense, the technology-enhanced defense systems that are out there. How do you find the right people, developing a workforce, how do you find those right people to come into the military services and operate these type of technically enhanced systems? And are the recruiting areas that we used previously applicable for today? It was a great discussion. And the same discussion has to happen in the unmanned systems on the flight operations. When we go out and we recruit, let's say, fighter pilots today, there's certain criteria that we've established, certain tests that we put in over time that we realize will identify characteristics that are usually the most successful for operating those vehicles. But are those characteristics that we're looking for with these types of screening devices the most appropriate to identify the people, the humans, that will be successful in operating unmanned systems? I don't know that answer right now, but I would argue that we need to look at that, because the gut reaction anecdotally would say that it's probably different. Human-machine interface and interaction. What do we lean on the machine to tell us, and then how do we interact with the machine so we become a effective system operating together? Interface design, CRM, automation, situational awareness. There's a lot of different components from a human perspective and skill sets that you might need to have. Another example of the different type of person skill sets going to be required to operate an unmanned system that we need to consider. This year I have 3 children. The middle one is 9 years old. This year the 9-year-old wanted a small UAS, so I bought him a little quad rotor. And it took me months and thousands of dollars to learn how to fly. I bought him this for Christmas, and within 2 hours.
والسادة ضيوفنا الكرام، نرحب بكم في معرض الدفاع الدولي ايدكس 2015 وندعو السادة حاملي بطاقات دعوة حضور إعادة حفل الافتتاح للتوجه لأخذ مقاعدهم في مدرج أدمك وشكرا.
Should I do anything? We're okay? It wasn't a fire drill. My 9-year-old son had this device. He took it out of the box. He took it to his iPad mini. He went to iTunes. He downloaded operating device. And within probably 35 minutes, he was showing me how he could make it do loops in the living room of our home. The skill set that young folks today have just naturally lends itself a lot to what we're doing in unmanned systems. So we have to consider that, not only where we're recruiting, but how we train, and again, what those training criteria would be.
Ladies and gentlemen, good morning and a warm welcome to IDEX 2015. May I now invite those of you who have an invitation to attend the IDEX 2015 opening ceremony repeat to kindly make their way to the grandstand and take your seats. Thank you.
Great, thank you. But all this leads into all this understanding of the different type of human considerations that we have to have in this operating environment of the UAS lends itself to the qualifications and standards. What are the standards today? And you heard some of our colleagues up here mention this morning from industry. They're basically doing these on an industry.
وندعو السادة حاملي بطاقات دعوة حضور إعادة حفل الافتتاح للتوجه لأخذ مقعدهم في مدرج أدمك وشكرا.
Great. So a lot of our industry are doing this training today, but it's stovepiped, and we don't have a broad application of what this criteria would be. If you're a certified air transport pilot today, you can enter the industry.
Ladies and gentlemen, good morning and a warm welcome to IDEX 2015. May I now invite those of you who have an invitation to attend the IDEX 2015 opening ceremony repeat to kindly make their way to the grandstand and take your seats. Thank you.
Nobody sent me my invitation. It's in the mail. I'm waiting on the invitation still. But the systems that are out there today, or the training that's going out today, is very specific to a certain platform, to a certain operational environment. We've got to take that a little broader, and we've got to take that into something that would be applicable across multiple platforms. We don't train manned pilots to operate only a 787 or an A380. We train pilots to be pilots, and then they're able to integrate into those systems differently. The certification level is a little different. We've got to consider that. The next generation of U.S. pilot, we talked about that. What kind of skill sets? It's going to be a little different. I think we'd all agree that the skill sets are going to be different. It's going to have an impact on how we do training. It's going to have an impact on how we do certifications. I'll give you a classic example of this. We heard a little bit, or just briefly in our previous session, that the Federal Aviation Administration in the United States over last weekend issued a notice of proposed rulemaking. It's the first step in establishing policy. And that notice of proposed rulemaking was applicable to small UAS operating in a national airspace system. And it basically said that if you're under 55 pounds, and forgive me, I don't know that I didn't memorize the kilos, but relatively small and under 500 feet, and it was daytime and line of sight, you could basically operate that vehicle with about 300 hours worth of training, I think is what was involved in that, just some basic training. But it did not require any flight in that training whatsoever. And that's a big deal. That's a big difference. So they're saying that you can operate these small UAS in the National Airspace System. Of course, we're below 500 feet, but you can do that without ever demonstrating the capability of safely operating or flying the vehicle. You're doing it through just an understanding of the system that you're operating in and the requirements of that system. That's a big difference. That's a big change, a big step away from what we're doing today in the training environment. But it also allows us to do training that was mentioned earlier without having a vehicle involved at all. We could do it completely through simulation. Again, game changing. This is a different approach to training and certification. That policy obviously is just a notice at this point. If it does become policy, I think you'll see a lot of different ways that folks are engaged training, and we're going to basically show up in the parking lot of your building and be able to teach you how to fly these vehicles and do it to a certification level and never visit the airport. The number of vehicles that you can control has to be considered there too. And as I mentioned, when you step into that environment and you're able to do training and to a certification level without ever going into an airport, without never being around your typical manned pilots, without possibly ever understanding the culture, the safety culture that's involved in aviation, what does that do? Is there a risk there? And I would say, and now this is a problem that the regulators have to solve in reality, but also the educators. And this is, do people that have never been exposed to the culture of aviation, if they're allowed to operate these vehicles in the airspace, and we know they will, we know this is the right thing to do, we know that we can operate these vehicles and train people to operate these vehicles safely in an airspace system, but there's a component of this that we cannot forget, and that's the safety culture that's involved in aviation. So what should the barriers be to entry? Right now, what we're seeing on very small UAS in the United States is the barrier is going to be relatively low, which has an impact. And we would ask, is that a risk? Because if we were to say that you had to have at least a private pilot's license to be able to operate, and I'm not saying that's necessary, because obviously the skill sets there are significantly different from what would be needed to operate the UAS. But if we're saying if that's the minimum barrier to entry, that does, without a doubt, eliminate a lot of folks from being able to operate in that system because they would not be willing or able to achieve that certificate level. So there's a lot of discussions now about is not only what training is necessary, but what should the barriers be. We don't let everybody operate in the national airspace system. That's why aviation is the safest mode of travel there is. The people that are operating in that system have a very good understanding of the safety culture involved. How do we take that same culture, that same understanding, and integrate it into the training and the certification standards that we would be employing for our unmanned systems? Certainly challenges, but challenges that I think everybody in this room, certainly everybody at this conference, most everybody at this conference, would agree that we can certainly accommodate. All right, typically I'd open this up to questions, but I don't think they're having questions, but I left a slide up there because I thought it was a great slide. It shows the difference between what the manned folks are having as they step into the unmanned systems operations. So I wanted to say thank you for your time, and I appreciate it. I hope you're enjoying the conference. And again, I'd like to say to our host, thank you so much for your hospitality. We certainly do appreciate that as well.